A simple one to start with. Solids can be categorized into conductors, semiconductors, and insulators. By their ability to conduct electricity. The energy levels of individual atoms become combined into energy bands in solids. Where the atoms are closely packed together. And so share their energy levels. Now I'll put 3, 4 and 5 together. And they kind of all go hand in hand. So in band theory, materials can conduct when the highest band is partially full. So that applies to all. But if we then look at that for conductors, insulators and semiconductors, for conductors, and sorry, another thing I should say, that the highest band is also called the valence band, which is full. For conductors, what we find is that the valence band kind of goes all the way up to there, and the conduction band, which is the next band up above the most fullest band, they partially overlap, which means that the conduction band is partially full but not completely full, and therefore conduction can take place. In a semiconductor, you have a small band gap between the valence band and the conduction band. And so that's a small gap where there are no energy levels, so electrons can't exist. But electrons can jump across that small gap, and therefore you can have some electrons in the conduction band, and therefore you can have conduction because you've got a partially full band. And you can adapt how many electrons are in there by, for instance, heating it. But we'll talk about that in learning outcome 6. And for an insulator, then there's a large gap between the valence band and the conduction band. I should have labelled all these actually as well. Do it a different colour. So this is your conductor, semiconductor, and insulator. And in the insulator then, what that means is it would be very difficult to get electrons from the valence band into the conduction band without putting in so much energy that you break the material. It can be done. Lightning is an example of that. But basically after lightning you're affecting the gases involved. And then the last bit in this chapter is that when you heat a semiconductor, more electrons have enough energy to make it across the band gap into the conduction band. And so more current can flow. So that's the basis, for instance, of a thermistor that you made at NAT 5. Now there should really be a seventh learning outcome as well about doping. So doping means introducing small amounts of a different material when growing a semiconductor. And that's the other main way that we can alter conduction properties of a semiconductor. So temperature is one, but doping would mean introducing a material with one more valence electron or one less. And if you introduce with one more valence electron, that's called n-type. And then basically what you have then is your valence band, small gap to your conduction band, if your valence band is full, then what you'll have is those extra electrons. So if you introduce a material with an extra valence electron, then they'll appear in the conduction band, adding to the amount of conduction that can take place. And if you do the opposite and introduce a material with one less electron, then what you have are holes where electrons should be. And basically electrons can use that to flow. So basically you no longer have a full valence band, so conduction can take place in the valence band if it's not completely full. And these holes are like stepping stones that the electrons can use to move through the material.